Good morning, everybody. My name is Michael Fiebig. I'm with Fiebig Architecture, and today we are going to do a quick lesson on a very important aspect of building design and construction, and that is understanding the difference between combustible and non-combustible construction. So let's talk about this. First things, combustibility is different than fireproofing. So there are two main aspects to passive fire protection in buildings. And of course, passive fire protection, we're talking about the ability of the building itself to resist the effects of fire. Contrast that with active fire protection, which would be things like fire sprinkler systems, fire alarms, smoke alarms, things that actively that activate in the presence of a fire. So there are two main aspects to passive fire protection in buildings: the combustibility classification of the materials and the fire resistance rating, commonly just referred to as fireproofing. So fire resistance ratings, those are measured in hours, generally 1, 2, 3, or 4 hour rated systems, and rely on a treatment applied to the building elements to resist the effects of fire on a building. That would be things like spray applied fireproofing, gypsum wrapping, intumescent paints, etc. And that's that's generally the first thing that comes to mind when a designer is thinking about the fire rating of a building, is what rating it actually has to be. How long does the building or the building element in question have to resist fire? And that's where the 1, 2, 3, or 4 hour rated element comes in. And of course, depending on the type of treatment, you can get different rated ratings. But combustibility, on the other hand, this is different. Combustibility is how the building element itself responds to the fire, meaning, can the building element be ignited? Is it fuel for a fire? Can it be consumed by the fire? Think wood, of course. Wood-based building materials are combustible. They can be ignited. They can burn. They are consumed by a fire. And on the contrary, a non-combustible material is one that cannot be ignited and will not be consumed by the fire. Now, that's not to say it's not affected by fire, because even non-combustible materials are affected by fire, but is the material consumed by the fire? And can it sustain a fire? Is it fuel for a fire? One way you can think about this is if you apply a flame to it, will it burn? Will it catch fire and burn? So of course, when you're thinking about wood, yes, if you hold a flame to wood, it'll ignite and self-sustain the fire and burn and ultimately be consumed. Whereas a piece of steel, let's say you have a steel beam or a steel stud, you can hold a flame to it, and while the flame will of course heat up the element and it'll get hot, it won't ignite, meaning once you pull the flame away from the steel element, the fire is gone. It doesn't sustain a fire by itself. So per the commentary, this is going to be from the 2018 IBC, and this is the commentary for chapter 6 for construction types. And here's what it says. The purpose of classifying buildings or structures by their type of construction is to account for the response or participation that a building structure will have in a fire condition originating within the building as a result of its occupancy or fuel load. The code requires every building to be classified as one of 5 possible types of construction: type 1, 2, 3, 4, or 5. Each type of construction denotes the kinds of materials that are permitted to be used, i.e. non-combustible steel, concrete, masonry; combustible wood or plastic; or heavy timber, HT, and the minimum fire resistance ratings that are associated with the structural elements in a building having that classification, i.e. 0, 1, 1.5, 2, or 3 hours. Now, you'll notice in that first section, it does make the distinction. It's either non-combustible or combustible, and the minimum fire resistance ratings associated with it. So you can have non-combustible fireproofed buildings, you can have non-combustible non-fireproofed buildings, you can have combustible fireproofed buildings and combustible non-fireproofed. And of course, when I say fireproofed, I mean with fire resistance rated materials applied to it, generally referred to as fireproofing. So the point is you have essentially four different types of buildings that you're looking at here. Let's see, types 1 and 2 construction consists of building elements that are non-combustible. Buildings of type 3 construction have non-combustible exterior walls and combustible or non-combustible interior elements. Type 4 construction identifies those structures with non-combustible exterior walls and heavy timber interior elements. Type 5 buildings are permitted to have building elements that are either combustible or non-combustible or a combination of both. Types 1, 2, 3, and 5 construction are further subdivided into two categories, A and B, that identify differences in degree of fire resistance required. So, it's more than four, but those four basic elements are what drive the ultimate classification of the construction type and fire resistance rating. It all comes down to the type of rating required and whether or not the materials are combustible or non-combustible. So the code also has non-combustibility tests. These are basically how you establish whether or not a material is going to be considered combustible or non-combustible. As it says, 703.5 non-combustibility tests. The tests indicated shall serve as criteria for acceptance of building materials as set forth in sections 602 for types 1, 2, 3, and 4 construction. You'll see that the elementary materials, meaning the basic material that it's made of, that's required to be non-combustible, shall be tested in accordance with ASTM E136. And that test is the standard test method for assessing combustibility of materials using a vertical tube furnace at 750 degrees Celsius. So 750 degrees Celsius equates to 1,382 degrees Fahrenheit. So that's a fairly high temperature. That's a lot of heat applied to the material. So right off the bat, you can imagine any sort of wood material is certainly not going to be able to endure 1,382 degrees Fahrenheit. It'll burn up pretty quick. So that's why things like steel and masonry are much more commonly associated with non-combustible materials, because a concrete block can endure that temperature and it'll still remain. Same thing for steel. Again, it's not that the heat doesn't affect the material; it's that it won't be consumed or destroyed by the heat. So let's look at Table 601 of the code. This details the hourly ratings. Again, colloquially, fireproofing required for the 5 different construction types. And you can see of those 5 construction types, 1, 2, 3, 4, and 5, this table is really breaking it down into the ratings. So the amount of fire resistance required to be provided to protect these building elements based on the type of construction. But if you remember from what we just read in the commentary, types 1 and 2 construction are non-combustible. Types 3 and 4 construction are a combination of combustible and non-combustible. And type 5, while type 5 is properly defined as any material allowed, in practice, type 5 construction is generally just combustible. When you talk about type 5 buildings, you really generally are talking about wood framed, stick framed, wood sheathed structures. But technically you could do a type 5 building out of concrete and steel if you wanted, but it's just not very common. So typically type 5 is going to be combustible materials. And then of course, the higher up the chart you go, non-combustible becomes the rule. So let's just give an example of what the significance of this is. Just as an example, we're going to look at the allowable area factor. That means how big the building is allowed to be based on its construction type. And you'll see that In this example, we're just going to be using occupancy group A. That's the assembly occupancy classification. But you can see that when you go to type 5, which again, we're going to be considering basically combustible materials, and type 5B, meaning it's not protected, you're limited, in this example, 5,500 square feet. So you're building of occupancy classification A1, so an assembly group, not sprinklered, you can really only have 5,500 square feet. So you're limited in size here. You really can't build a very big building out of combustible materials in this situation. But you can see that you go up the chart, once you hit type 2, which is non-combustible, and again, we're talking about no protection, so no fireproofing, just by virtue of the fact that it's a non-combustible material, it can be 3,000 square feet larger. So non-combustible unprotected buildings can be bigger than combustible unprotected buildings. And of course, that's not the only factor here. We also have to consider whether or not the building is sprinklered. That's what these footnotes are. That's what this means. NS means not sprinklered. S1 means sprinklered, but it's only one story. SM means it's sprinklered multiple stories. And of course, the level of fire protection afforded to the building elements. So of course, if you have the type 2B, but you protect, you give it an hourly rating in addition to its non-combustible materials, you really do increase the size of the building. And of course, you go up to type 1, which is the most restrictive non-combustible construction type, you get unlimited height, unlimited area. And so the point being that combustible buildings are limited in size compared to non-combustible buildings. You can have larger buildings if the building is non-combustible because it's safer. A non-combustible building is safer than a combustible building when it comes to fire. So there are exceptions to the rule, 26 to be specific in section 603 that talk about combustible material in types 1 and 2 construction. And we're not going to go through all 26, but we're just going to touch on a few of them. And one thing that you'll notice is the very first exception is fire retardant treated wood. Now, it's important just to understand that fire retardant treated wood is detailed under the combustible materials. So it's number 1 in the combustible material allowed, which means that fire retardant treated wood, while treated for additional fire resistance properties, is not considered a non-combustible material. There are lots of folks out there who refer to fire retardant treated wood as non-combustible wood or non-com wood. That's not accurate. Even FRT wood is considered combustible because even FRT wood can't survive in a blast furnace of over 1,300 degrees. The FRT wood provides a lot of benefits, and that's why it's allowed in some conditions in non-combustible buildings, but you can't use regular wood where you'd be able to use FRT wood in this instance. So you can see this exception number 1. It says FRT wood is permitted in non-bearing partitions with less than 2-hour fire resistance rating required, non-bearing exterior walls where fire resistance construction is not required, and then of course roof construction, including girders, trusses, framing, and decking, and then balconies, porches, decks. So in a non-combustible construction type, you can use FRT wood in these instances. You can't use non-FRT wood though, meaning you can't use standard untreated wood in these in this capacity. You can only use FRT wood. And again, this is an exception to the requirement for non-combustible materials. So a few more exceptions. Thermal and acoustical insulation. You've got foam plastic in accordance with chapter 26, roof coverings, interior floor finishes, millwork, interior wall and ceiling finishes, trim. These sorts of things are allowed to be combustible because these just have a much lower effect on the overall performance of the building. when compared to the primary building elements that we saw in Table 601. Things like the primary structural frame of the building, floor construction, roof construction, exterior wall construction. Those things are much more significant. Those are the ones where the non-combustibility classification really matters, because those are the primary elements of the building. These exceptions are allowed because they won't have as big of an impact on the overall performance of a building in a fire event as would the primary building elements. Let's see, number 12, stages and platforms. 13, combustible exterior wall coverings. That's going to be things like your claddings. There are some exceptions that will allow like wood siding and wood-based claddings on an exterior wall. That's different than the actual wall structure itself, meaning you can have a non-combustible wall structure, and in some cases you can have a combustible cladding, meaning think of something like a steel stud exterior wall, a steel framed wall that happens to have some wood siding on it. In that case, the more important element is the actual frame, the structural frame of the wall, meaning the studs. But the cladding in some cases can be combustible in accordance with these sections. And then of course, things like blocking for handrails, millwork, cabinets, window and door frames, those are allowed to be combustible as well. So let's see here, the final takeaway: as a designer of record, understanding the differences between combustible and non-combustible building materials is crucial for compliant design. Designing or specifying combustible materials where not allowed in buildings where increases in height or area have been granted due to classifying the building as non-combustible can have a devastating impact on the final construction. Once more, let's look at the commentary. Chapter 5, building height and area. Here's what the commentary says. Chapter 5 is an important chapter in the code because many other code requirements depend on the establishment of the minimum required type of construction for the building. A construction type must be established for each building. Then, with consideration of the occupancy or occupancies, the maximum allowable height, number of stories, and building area can be established. Without the correct determination of the minimum type of construction, misapplication of the code is probable. Sections 504 and 506 provide the foundation for setting thresholds for building size based on the building's use and the materials with which it is constructed. The aim is to reduce risk of injury to an acceptable level for building occupants by limiting fire load and fire hazards relating to height, area, and occupancy. So again, it's focused on limiting fire hazards, limiting the dangers associated with fire. And when you're talking about dangers associated with fire, combustibility and non-combustibility are one of the most significant, those are some of the most significant factors in that question. Let's look at what the purpose of this chapter is. Following occupancy classification of uses based on Chapter 3, the code review for the design of any building continues with Chapter 5 with the determination of the minimum required type of construction based on the use and size of the building. Misapplication of Chapter 5 can result in a multitude of related errors in subsequent code applications, since many code requirements depend on the type of construction that is required for the building. The main purpose of Chapter 5 is to regulate the size of structures based on the specific hazards associated with their occupancy and the materials of which they are constructed. Chapter 5 also provides for adjustments to the allowable area and height based on the presence of fire protection systems. So that being said, that's the end of today's lesson. Once again, just trying to emphasize the importance of understanding combustible materials and non-combustible materials. If you're an architect or a building designer, you want to make sure that whatever materials you use or specify in the building comply with the construction type assigned to that building, in order to make sure that the building is appropriate in its size, height, number of stories, area, based on those materials. So with that being said, that's the end of today's lesson. Thank you for watching. If you have questions, please hit our website, fiebigarch.com, or our email, info@fiebigarch.com. We're always happy to help answer any questions you may have. Again, my name is Michael Fiebig. with Fiebig Architecture. Thank you very much and have a great day.